Hello, GIS class. We are looking at the relationship between house value, race, and proximity to our oil refineries in Louisiana. My name's Johnny,
Sarah.
I'm Lucy.
and
We've chose this topic because we've noticed that many environmental problems disproportionately impact lower income minorities than wealthy whites. And Louisiana has one of the highest income inequality rates in the United States. We also noticed that closer proximity to air pollution sources results into greater likelihood for respiratory illnesses, cancer, and poor air quality. So we aim to show underlying demographics around point pollution sources. And our research question was, how are house value, race, and proximity to oil refineries related, if related at all? And what sociological data can be pulled from these conclusions? For methodology, we used 4 steps. So we acquired our data from 2019 ESRI population and housing feature layer that we found in ESRI's Living Atlas. And then we created new feature layer of race and housing values separately from the Living Atlas by filtering for Louisiana only data. Then we took data by tract and symbolized them using dot density map. And for housing values specifically, we summarized the 12 categories into just 3 categories to clear our data more. So that's how we ended up with 3 categories that we can see in our house value categories. And we used that specific layer because we couldn't find any good data on the average household income in Louisiana for 2019. So we thought that we can use house value categories to represent that in a certain way. Then we made 2 separate maps, one with the racial distribution and one with house values separately in dot density maps, and created buffers around oil refineries for both of those maps of 2, 5, 10, and 20 miles. And I was spatially joined these 2 dot density maps to the buffers and created 2 layouts that represent those 2 maps separately.
Yeah, and then for the data analyses, we used two specific columns in the attribute tables, which was the home value by buffer and the race by buffer, which practically aggregated the number of cases within each buffer region. And then we divided by the number of cases total to get the total proportion within each buffer of house value or race, depending on which map we were looking at. So more specifically for qualitative methods, we used buffers. We used 2-mile, 5-mile, 10-mile, and 20-mile buffers, which you can see is symbolized on the right. And for our dot density map, each dot represented around 600 instances of the category we were looking at, and that's also symbolized on the right in the map. For quantitative methods, like I said before, we used 2 main columns in the attribute tables, which is the home value by buffer and the race by buffer. And for the home value by buffer, we used 3 separate categories. And as Lucy said earlier, we use these categories. We use the top 4, the middle 4, and the highest 4 house values found in the original data layer to simplify the data and to see it better visually on our maps. So the results for the home value distribution, we found that 99% of all the houses from 2 all the way to 20 miles out were under $200,000. And yeah, so you could see that. And then there were very few instances, as you can see in the table, of houses that were between 200,000 to 500,000, and then even above 500,000. The percentages were very, very small compared to those that were less than 200,000. And then for the racial distribution, as you can see, it remains pretty steady throughout the 2, 5, 10, and 20-mile buffers, where the majority, 98 up to 99% of people were non-Hispanic whites, and the minority obviously makes up a very small percentage of these people. And again, we did that by aggregating the number of cases within each buffer, the 2, 5, 10, and 20 miles, then divided by the total number of people present in that buffer to get the percentages of the distribution of races within each buffer region. And so just to summarize some overall results, majority of houses 2 to 5 miles away, even to 20 miles, which is our highest buffer, was under $200,000. And there was very, very few instances of houses that were over $200,000. So yeah, even 20 miles away, 99% of the houses still cost less than $200,000. And then racially, approximately 99% steadily 2 to 20 miles away from the point source oil refinery were not Hispanic whites rather than minorities.
Housing values under $200,000 account for a significant proportion of the houses, even 20 miles away from an oil refinery. Additionally, even though minorities make up about half of the Louisiana population, they only account for 1% of the population that lives within 20 miles from an oil refinery. We thought this was extremely surprising, both because it goes against our hypothesis and also because that number is really low for anywhere. This could have been for a couple reasons. One thought was that it was the census data might have been incorrect or flawed, and that's the data that we used. So yeah. Here are the maps again that you can look at. You can see, again, the home value distribution in Louisiana and the race population distribution in Louisiana. As you can see that we have mostly the light pink dots everywhere. This could show that maybe having the baseline at $200,000 was a little bit too high. Maybe house values across Louisiana are not very high. Additionally, we couldn't have used household income. Maybe that was a better metric for looking at how wealthy people were. Some limitations in our project were that we used house value instead of household income, which I just talked about. We approximated buffer sizes in relation to air quality improvement. We used 2, 5, 10, and 20 miles. Additionally, further research should be conducted to establish the health consequences of populations living close to point pollution sources and to quantify the air quality changes in the buffers. Obviously, this is outside the scope of our GIS project, but it's something that's really interesting that should be looked at. In conclusion, we asked the original question: how are house value, race, and proximity to oil refineries related, and what sociological data can be pulled from these conclusions? So originally, we thought that the closer you were to an oil refinery, there would be a larger proportion of minorities and lower housing values, and that would change as you moved away from these sources. However, we found that that was completely wrong. Housing values remained stable under 200,000 miles, even 20 miles away. There was insignificant change. And racial distribution reflected that a large non-Hispanic white population throughout all buffered regions.